Yes, so my work at the Department of Forestry, Fisheries and the Environment is to lead the National Oceans and Coastal Information Management System, or OSIMS for short. My presentation is a little bit wider in scope than just covering the maritime domain awareness. I just wanted to give you a little bit of an overview of what OSIMS is. So OSIMS is a project which aims to improve governance and management of South Africa's oceans and coast, as well as promote the ocean economy. It is funded by the Operation Pakisa Ocean Economy Portfolio. And it serves, it distributes decision support tools to stakeholders through across a number of themes, going from marine spatial planning, coastal flood hazard, maritime domain awareness, fisheries and aquaculture, and others. The project builds on a wide range of partnerships across many government institutes, but also across non-profit organizations and some industry sectors. And we essentially cover different aspects. We do both data management through the Marine Information Management System, where we store in situ data principally from the branch, but other stakeholders as well. We run models and we aim to provide value-added products that helps in decision making. As Tommy, Dr. Borman said, we have a very big area to cover and to protect around the South African coastline. Of course, the EEZ is very large, but also in the Southern Ocean and around the islands, Southern Ocean islands. So one of the tools that is deployed on the OSIMS is the Integrated Vessel Tracking Tool. And this tool supports the State Security Agency, the Department of Defense. It is used by the South African Maritime Safety Agency, the Navy, and also to help with the marine pollution monitoring. So this tool uses both AIS data that was provided to us by the South African Maritime Safety Agency. And it's one of their contributions to the project. So this is how stakeholders contribute to the project, sometimes by in-kind contributions. And we use AIS data to detect anomalous behavior in fishing vessels. And we combine this AIS data with synthetic aperture radar data as well from both RadarSat and the Sentinel-1 series. So we also directly engage with our stakeholders. We use telegrams to provide systematic reports and alerts when vessels display anomalous behavior, such as slowing down next to marine protected areas. And yes, so the tool is actually really used quite a lot by enforcement agencies, and it's been quite successful. The SAR data is also used to identify potential regions of problems, what we call dark targets. And this is a map that shows, the amount of time that vessels were detected in the SAR imagery, but did not have the AIS system on. And you can see that there is a large concentration of these dark targets right at the edge of our economic exclusive zones, as well as near some of the marine protected areas. For example, near Saldanha Bay on the western coastline of South Africa. So this is good. This is good for us to basically have more targeted response and strategic, to understand the strategic response needed in certain areas around the coastline. We've had some success thanks to this tool. It's supported enforcement and helped in the arrest of a number of ships and prosecutions. And these are just some of the examples that we could find in the press, where it's led to the arrest of both illegal activities related to drug smuggling or illegal fishing activities. So yes, this is a tool that has quite strong economic value for us. Now moving on a little bit further away to other things that we do, we also have used satellite data extensively to support fisheries and aquaculture. And in particular, we've got a tool based on the Sentinel-1, essentially data that looks at harmful algal blooms and provide alerts to stakeholders, and also a dashboard to highlight regions around the coastline that are at high risk of algal blooms and that should be monitored closely. And as you see on the conversation on the right-hand side, we use WhatsApp groups during high-risk periods to communicate with our stakeholders. And this is used directly by some of our aquaculture partners. Again, that tool has had some impact on our ocean economy because before the tool was implemented, we had a very disastrous red tide, which caused a 70 million rand loss for the sector, and also stock losses. And since we implemented the tools, there has not been any major losses to the industry. So it's another success story for us. We do also marine water quality. This is really in the early stages of development. And again, using very high resolution Sentinel data for this. But what is missing at the moment is a lot of in-situ information to corroborate the satellite outputs and look at pollution or effluent blooms, etc. And one thing that we do to try and mitigate that at the moment is we are developing data capture apps to facilitate the uploads from our national institutes, such as the Walter Sisulu Lab, that takes regular samples in the ocean around the coastline. So they're now using an app to upload directly the data onto our system. So hopefully in the future, we have more in-situ data coming through and helping us assessing pollution around the coastline. Another thing that is done through one of our major service provider, which is a South African Environmental Observation Network, SEON, is the development of ocean models. And this is done in two ways. The one way is to look at historical changes, understand the climate changes, dynamic changes over the last 30 years using hindcast models. And this is the model you see on the left-hand side, which is being developed at the moment at 3-kilometer resolution. So this allows us to get more understanding of the environment that we are in. And the other approach is to actually develop high-resolution forecast models in specific area. And we've started this effort by developing a model around Algoa Bay. And this is actually at the moment working. It's still in the preliminary stage, so it's not yet used within the decision support tools that we have on our websites, but it will be in the future and can support also the IVT test, with the provision of more accurate ocean forecasts. The high resolution model can also support us in mitigating pollution risk. For example, in the area where the forecast is provided, we have bunkering operations happening very close to a penguin colony. And at the moment, what we do is we routinely deploy virtual particles in the model to track what would be the impact of an oil spill in the sites where the bunkering is taking place and where the oil would go. So this is something also to help us, mitigate risk around the coastline. Other things that we do are development of products, value-added product from satellites. For example, we do eddy tracking, and we have developed a regional algorithm to track the position of the Agaras current in real time, and also using the forecast models. And this can be used not only to monitor climate variability, but also to support, improving the fishing route or or understanding, the ocean conditions better. So yes, thanks. Just wanted before to finish that one of our some of our successes are essentially in part thanks to continued stakeholders engagement. Like each of the decision support tools that has been developed has technical advisory groups where both developers and stakeholders have opportunities to engage and participate in the development of the products. Thank you. Now we'll stop here.